Today we are going to take a look at part 2 of completing the square. So again, our objective for today is to solve quadratic equations by completing the square. And when you're done today, you will be able to do a problem much like what is seen here in the do right here. And for our wick or no undo, the idea of square or perfect square. Remember, if I talk about a perfect square, I'm talking about things for example, 36. The perfect square of 36 is 6. The perfect square of 49 is 7, and so on and so forth. And then our essential question today, what is the square or perfect square? So what is a square or perfect square, which is what I just kind of talked about. All right, well, let's go ahead and begin our lesson for today. Our main vocabulary word for today is completing the square. So let's go ahead and learn how to do that. Before we begin, let's take a look at a problem. And let's just review for just a moment. If you take a look at this and you look here at the left side of the problem, you will notice that this is a perfect square trinomial. Now, remember from last time, part 1, if 16 right here is a perfect square, which it is, and the perfect square of that is 4, and if x squared is a perfect square, and the square of that, perfect square of that is x, and if you take that and times it by 2, that would give you 8x. And then notice what is right here. If this is 8x, then that means this side is a perfect square trinomial. Which means when you factor this, it will factor into something that looks like this. You're going to be x plus a 4, and then x plus a 4. And I'm going to go ahead and carry this 49 down, of which this equals x plus 4, the quantity squared, equaling 49. Now at this point, our job was to solve for x. In order to solve for x, I have to ask myself, what is the opposite operation of square? And if you said square root, then I agree. So we're going to take the square root of both sides. In doing so, we end up with x plus 4 equals, now remember when you take the square root of both sides, it's plus or minus, and the square root of 49 is 7. Now at this point I am going to subtract 4 to both sides. So that means I will get x is equal to 4 plus 7, but I also get 4 minus 7. So my answer here in set builder notation will look like 11 and negative 3. Okay, so that's enough review. Let's go on into our new material today. Today what we're going to take a look at is what happens when our quadratic equation is not a perfect square. Can we model it to be a perfect square? And the answer to that is yes. Okay, so I would like you to write down this definition of completing the square. So if a quadratic expression of the form x squared plus bx cannot model a square, you can add a term to form a perfect square trinomial. And that's what we're going to do. So let's go ahead and let's look at this. If I have x squared plus 6x right here, what could be my number here that would make it a perfect square? In other words, what number could I add to here that when you factored it, those factors would give you the inside-outside check, giving you 6. Now some of you are probably already jumping all over this and you're saying, hey, it's got to be 9 because 3 plus 3 is 6. Well, you know what? I'm with you 100%. Now, how did you go about doing this? Let me show you a shortcut here. If we take the linear term right here, this 6, and we take half of it, and then we square it, that'll give us the number that goes right there. So notice, if I take 6 divided by 2, which gives me 3, 3 squared is 9, I will add a 9 here, And what that does is it gives us a perfect square trinomial. So then when I factor it, it's x plus 3, the quantity squared. Now how do I make this work for everything? Well, I have my b value here. You're going to take that b value, you're going to take half of it, and then you're going to square it. So in here you'll have x plus b over 2, and that will be the quantity squared, and that will be the factored of the perfect square trinomial in this situation. Alright, so let's go ahead and let's practice here. Okay, so I have x squared minus a 7x plus a what? Well, according to what we just said, we're going to take 14, we're going to take half of negative 14. Half of negative 14 is negative 7. And then if we square that negative 7, that gives us a 49. So what number should go there? If you said 49, I agree with you. Okay, so let's go ahead and uncover this. So we took half of negative 14, which gave us negative 7. Then we're going to square that, and the square of negative 7 gives us 49. So that means our perfect square trinomial will be x squared minus a 14x plus a 49. And how does that factor? Well, when that factors, it's simply just going to be x minus a 7, the quantity squared. Okay, in your notes I want you to practice this one. Now, before we do this, I'd like you to go ahead and give it a try. So go ahead and pause the video, see if you can write this out, and then start it up here in a minute, and then we'll do it together. Okay, now that you've done this, let's go ahead and do this together. All right, so what's this going to be here? Well, let's see. We took half of 9. Ooh, wait a second. Half of 9. How do you do that? Well, guys, if you take half of 9, that's simply just 9 halves. And then we're going to take that and we're going to square it, which means that will give us 9 squared, 81, over 2 squared, which gives us 4. Oh, so sometimes when you're doing these perfect square trinomials, or you're creating a perfect square trinomial, sometimes it isn't always nice round integer answers. Sometimes we have fractional answers. Okay, so what's that going to look like? Well, let's see. It's going to be x to the second plus a 9x plus 9 over 2. Wait a second. Let's go ahead and let's just write it so it's all squared out. 81 over 4. Now, when we factor this, I'm going to show you a technique that is very helpful. If you'll just do what I just did right there, put x right there, and remember what we put right here, remember what we took half of right here, just take whatever is right there and put it down here. Notice it's a positive 9 halves, so put plus 9 halves right there. And when you do that, you have factored that perfect square trinomial, and it's all done. Okay, now from here, let's go ahead and I want you in your Cornell Notes to write these steps down. These are the steps for completing the square on a quadratic equation. Okay, not just a quadratic expression like we were just playing with, a quadratic equation. Okay, so step number 1, collect variable terms on one side of the equation and the constant on the other side. Now, what does that mean? Well, that means this constant right here is going to be over here on the right side, and this ax squared plus bx is going to be on the left side. All right, so what's next? Step number 2. For step number 2, if this a value right here is a 1, you can skip this step. But if it is not, then you're going to have to divide both sides by a to make the coefficient of the x squared term a1. In other words, you're going to divide everything on both sides by an a value. Okay, step number 3. Step number 3, complete the square by adding b over 2, the quantity squared, to both sides of the equation, just like we did on the previous couple slides. Step number 4, you're going to factor the variable expression as a perfect square trinomial. So you're just going to factor it, just like what we did on the previous slide, using that little technique that I just showed you. Step number 5, you're going to take the square root of both sides in order to get rid of the square. And then the last thing you're going to do is you're going to solve for the solve for the values of the variable. In other words, you solve for x. And remember, when you solve for x, you always put your answer in set builder notation. Okay, go ahead and pause the video a second so you can get these down. Okay, now that you have written those down in your Cornell Notes, I want you to take out your flip chart. And I want you to turn to a new page in your flip chart. Now the title for your flip chart, Completing the Square. And then if you would real quickly please, write these 6 steps down in your flip chart. Because on an exam, we might allow you, I'm not going to commit for sure, but we might allow you to use this flip chart on an exam. Okay, let's go ahead and go back to your Cornell Notes and let's put this example down in your notes. So here's our problem. Notice this time the x squared is on the left and the 12x minus 20 is on the right. Remember, step number 1, you need to collect all the terms of variables on the left side. So that means I need to take this 12x and move it over to this side. So how do I go about doing that? Well, you're simply going to subtract 12x to both sides. Okay, so again, you're just going to minus 12x here, minus 12x here, and then you notice that these two terms right here and right here are unlike terms, so you just write them out. Now take a look at this step here. At this step, you will notice that you have your terms of variables on the left and your constant on the right. So now we're ready to complete the square. Wait a second here. Step 2 says you need to divide by the a value. But remember, if your a value is already a 1, like this one is, see, you don't see anything in front of there, so your a value is a 1. But if your a value is anything other than a 1, you would have to divide everything on both sides by that a value. But since it is equal to 1, we can skip that step and go right on to step number 3. For step number 3, you are going to take half of negative 12. Now let me let you in on a little bit of a secret that I like to do, a little technique that I like to do. I like to spread this out to set it up to complete the square before I take half of the negative 12. In other words, I am going to put a little square right here and one right here. So I spread it out, creating some space here. Then I take half a negative 12. Half a negative 12 is? Yep, negative 6. Then we're going to take that negative 6 and square it. So what is negative 6 squared? Now remember, here's a place where students sometimes make mistakes. I said negative 6, we're going to square negative 6. That means you're going to, if you were to just punch this into your calculator, that means you're going to take negative 12, you're going to take half of that, and then you're going to square that whole thing and add that value to both sides. Don't punch it into your calculator without putting that parenthesis and then putting the negative. If you don't do that, what's going to happen is it's going to come out to be a negative 36 instead of a positive 36. All right, moving on. So we're going to go ahead and add that to both sides, and then we're going to simplify. In simplifying this, you end up with x squared minus a 12x plus a 36. We added that to both sides. Now we're just going to simplify here. So negative 20 plus 36 is going to give us 16. All right. So now let's push this up just a little bit so we can continue. Now notice what I did right here. I factored this. When you factor it, remember, it's a perfect square trinomial. You've made it to be a perfect square trinomial. So, and remember, always half of this is the number that's going to go right there. So x minus 6, the quantity squared. Next, we're going to take the square root of both sides. Okay, so in taking the square root of both sides, we take the square root here, take the square root there. You're left with x minus 6. Remember to put the plus or minus there. And the square root of 16 you know to be what? That's right. It's going to be 4. So you have x minus 6 plus or minus a 4. At this point, you're going to add 6 to both sides. And in doing that, now you have x is equal to, let's see, looks like a 10 and a 2. Now, remember, you added 6 to both sides in both cases, giving you 10 and a positive 2. All right, so your final answer, when you're all done, remember, you need to put it in set builder notation. So it's going to be x such that x is going to equal a 10, comma, and a 2. And you've just completed the square. Okay, now I'd like you to pause the video and I want you to try one by yourself. And then we'll go ahead and work through it here in a second. So go ahead and pause the video. Now that you have had a chance to work this, let's go ahead and work this together a little bit. Notice we have to collect the terms with variables on one side. So I need to get this 9x over here. And I need to collect the terms without variables onto the right side. How do I go about doing that? Well, let's see. We're going to subtract 9x to both sides. And in doing that, that gives us now x squared minus a 9x minus a 2 equals to a 0. Next, I need to collect this term right here, that constant, and get it on the right side. So I'm going to add a 2 to both sides, and I end up getting x squared minus a 9x. Now, I'm going to leave my square right there. Keeps it spread out, and I have 2 plus, and I'll put my square right there. Now notice, this negative 9, it is an odd number, which means we're going to get a fraction. But that's okay. We know how to handle that. So, we are going to take negative 9, you're going to take half of that, and then you're going to square that. So over here you took negative 9, half of that, and you're going to square that. So I will get x squared minus a 9x plus 81 over 4 equals 2 plus 81 over a 4. Now let's take a second and clean this up. I'm going to take and I'm going to add these two together. You can do it with a calculator, of course, or we can just quickly do it by hand. So let me come over here. If I have 2 over 1 plus 81 over 4, I'm going to multiply top and bottom by 4, giving us 8 over 4 plus 81 over 4, which gives me 89 over 4. Okay, so let's clean this up, and you know, as I'm writing this part down right here, I'm going to go ahead and write the factored form of it. So it's going to be x minus, remember the number that goes right here is always half of this number, so it's going to be 9 over 2 is equal to 89 over 4. Now from here, we have to get rid of the square. So I'm going to take the square root of both sides. Alright, so taking the square root of both sides, that will give us x minus 9 over 2 equals plus or minus the square root of 89 over, and the square root of 4 is 2. So I'm going to go ahead and simplify that as I go. All right, now let me pull this down, get a little room here. Now at this point here, I am going to add 9/2 to both sides. So if I add a 9 over 2 to both sides, plus 9 over 2, that is going to give us x is equal to 9 over 2 plus or minus the square root of 89 over 2. Now I can clean it up a little bit by saying x is equal to 9, because I have a common denominator. I can combine my numerators, so it'll be something like this, all over a 2. Now, I want you to notice here, I cannot simplify this because 89 is a prime number. I don't have any numbers that will divide into it besides 1 in itself. Okay, so when I'm all done here, I'm just going to put it in set builder notation, and I'm finished. This is a prime example where sometimes your answers come out very irrational. They're not rational, they're not integer answers. They're very irrational in this case. Okay, so excellent solution for a real life situation. Now let's try a problem where my a value is something other than 1. So first things first, I want to rearrange these. I'm going to put these in descending order. So 3x to the second plus 18x, and that equals 45. Now, notice right here, my a value is a 3. So that means I have to divide everything by that a value. After doing that, now I have x squared plus a 6x, and I am going to go ahead and put my little square there so I can complete the square, and this gives me 15 plus, and I'll put my little square there. Next, we're going to take half of this and square it. Well, half of 6 is 3. 3 squared is 9. So we're going to add a 9 to both sides. So that will give us, I'm going to go ahead and factor this side because I know it's just going to be x plus half of the 6, which is 3, squared. And over here, I know it's going to be 24. Now we're going to take the square root of both sides, giving us x plus 3 equals plus or minus. Now let's think about 24 here. 24, is there a perfect square in 24? Well, yeah, the perfect square in 24 is going to be 4. 4 times 6. And the square root of 4 is 2, leaving us with the square root of 6. Now I'm going to subtract 3 to both sides, and that gives me x is equal to negative 3 plus or minus the square root of 6. Now, I cannot simplify radical 6 any further than what I just did. So I'm going to leave it like that. Outside, I've just putting it in set builder notation, and that's done. Well, folks, that's it for today. That's the end of part 2. In next class period, we are going to be working on this problem set. So, with that in mind, we'll see you in class.